Here a system of equations of 4 variables, right? And what I want to do is solve this system using matrices, and particularly because obviously there are different methods to use matrices and solve a system, but I want to use matrices specifically with a matrix equation. So that's what we're practicing here. Okay, so let's first start with writing it in matrix form. So I have matrix form, AX is equal to B, where A is the coefficient matrix. So in this case, A, the coefficient matrix, which this is already set up in ordered W's, X's, Y's, and Z's. So my first column is going to be my W coefficient column, 2, 3, negative 1, 4. My second column in my coefficient is going to be my coefficients of X, which is 0, 0, 1, negative 1. And then my Y column coefficient, 1, looks like no Y in this, so 0, and then negative 2, and then 1, and then my Z's, 1, 1, 1, 0. So A is my coefficient matrix if I'm setting it up this particular way. X is the variable matrix, which in this case is a W, X, a Y, and a Z. Okay, so this is, we use capital letters to imply or to represent matrices, so this is a capital X representing the variable matrix, which in this case has these 4 variables. And then B is my constant matrix, which is everything to the right of the equal sign, so 6, 9, 4, and 6. Okay, so in order to solve this, I'm going to use the method of solving, a matrix equation. And technically, if this were not a matrix equation, if X were the unknown, you would divide both sides by A. So think of that as 1 over A, which is A to the negative 1, which is how we represent an inverse. So if I find the inverse, the multiplicative inverse of matrix A, and then multiply it by matrix B, then I get the unknowns, which represent matrix X. Then I'll get my unknowns and I'll solve my system. So the first thing we need to do is find the multiplicative inverse of A. And there are 2 ways to do it, right? If we were doing it by hand, we would set it up the way we did this one. We put the matrix that we want on the left, square matrix, the identity matrix corresponding to the same dimensions on the right. So this was a 3 by 3, so the identity matrix was a 3 by 3. This is a 4 by 4, so I would have to do the 4 by 4 identity matrix. And then manipulate this left side into the identity matrix. Once I do that, whatever's left here would be the inverse. That would be by hand, going through my row operations. Using the calculator. Using the calculator, I could do the same thing a little faster. Okay, I'm cheating, I guess you could say. But I could do it by hand too, so I'm okay, as long as you know how to do it both ways. So let's do it with the calculator, and we're going to input a 4 by 4 matrix. We put it into matrix A. So again, here on top, matrix, so I need to press second, and then this is X to the negative 1. I want to put it into matrix A. Let's go to edit and input there. Oops, over to edit. I'll put it into matrix A, enter. And it's a 4 by 4, so I have to tell it it's a 4, enter, by 4 matrix. Okay, so we're going to go across the top. So 2, 0, 1, 1, 2, enter, 0, enter, 1, 1. Cross row 2, 3, 0, 0, 1. Row 3, negative 1, 1, negative 2, 1. And then row 4, 4, negative 1, 1. 0, and then double check, make sure I didn't put anything in wrong too, because otherwise, make sure you do that, because then you're solving the wrong system. Okay, so this is my matrix A, 4 by 4 matrix. So let's go back, second mode, to my home screen. Let's just clear that out. And I want the inverse of matrix A. So let's go back into matrix to pull up matrix A, which is a 4 by 4 matrix, and then tell it I want the inverse of that. So this represents inverse. And then enter. And I have my inverse, right? So let's write that down. Back here. So 1 second. So I have Going across, negative 1, 2, negative 1, negative 1, negative 4, 9, negative 5, negative 6, 0, 1, negative 1, negative 1, and 3, negative 5, 3, 3. So I have my inverse matrix. Now, the rest of this you could do by hand, or you could do by the calculator as well. I'm just going to use the calculator because we've done this by hand. You want to multiply A inverse times B, right, to get matrix X, which is W, X, Y, and Z, right? I'm sorry, let me show you the screen back here. So I want matrix X, which is W, X, Y, Z, and that's equal to the product of A inverse and B. So A inverse times B. Now I could do that by hand, right? Multiply the two. And it's not really that bad if I do it by hand, but I'll do it on the calculator too because I don't think I ever showed you that. So I might as well just try it. So let's input B into my calculator, which is a 4 by 1 matrix. Let me share that with you again. Real quick. So let's go put it into matrix B. So second matrix, over to edit. And go to B, and let's put it in there. It's a 4 by 1 matrix. And matrix B was 6, 9, 4, 6. 6, 9, 4, 6. Right? Back to my home screen. I want to take this and multiply it by matrix B. In that order, right? Because it does matter which order I multiply matrices. And there's my answer. Again, I could do it by hand, or I could do it. No. Whatever floats your boat technically, because if I have a system of much larger matrices, I'm sorry, of much larger variables and matrices, I'm going to use my calculator check. So going down, I got 2, 1, negative 1, and 3. So therefore, my solution. I have that W is equal to 2, X is equal to 1, Y is equal to negative 1, and Z is equal to 3. Okay. This is my solution.